All right, so today we are going to talk a little bit about the Pythagorean theorem. With the way that we've had to go kind of out of order in this unit, this lesson should be pretty straightforward for you guys since we've been talking about the Pythagorean theorem since last Friday when we started trig. So what we're really going to do is just practice like some word problems, make sure we've got the setup good to go, and then talk about kind of an extension of the Pythagorean theorem as well. Excuse me. All right, so you guys all know the Pythagorean theorem is a squared plus b squared equals c squared. Okay. And so when we're looking at our right triangle, A and B are always the legs. And then C always has to be the hypotenuse. So it does not matter which leg is A and B as long as those are the legs and not the hypotenuse. Okay. All right. So from here on out too, all of your answers are expected to be written as simplified radicals unless stated otherwise. So you need to make sure that you either go back to that day 2 trig practice from Tuesday and review the end of that video where we talk about simplifying radicals if you did not get that far on Tuesday. So in this first problem right here, we've got two little right triangles. We've got this one and this one, and we're trying to solve for x. And so these markings, remember, mean that all those sides are congruent. So if this is 14, this is 14. And if this is 14, then this is 14. So if x is part of that right triangle right there, now we've got the two legs. And then that, since that's across from the right angle, that's our hypotenuse. So this would be 14 squared plus 14 squared equals x squared. Right? So that would be our A, our B, and our C. Okay, well, 14 squared. Oops. Uh-oh. There we go. Well, 14 squared plus 14 squared is 392. Okay, and so now to solve, I have to take the square root of each side, and I need to make sure I simplify that. Well, since we've got two 14 squareds here, that means that 14 squared is going to have to be a factor of this. So 14 squared is 196. And so this breaks down actually into 196 times 2, right? Again, because we've got two 14 squares. So 196 times 2. And so then when I take the square root of 196, that 2 cannot be simplified down any further. And so this side would be 14 radical 2. Again, that relationship only works because it's two 14 squares. All right, so now on this next one, our variable is one of the legs. So when we substitute these side lengths into the Pythagorean theorem, this would be radical 7 squared plus x squared, or x squared plus radical 7 squared equals radical 19 squared. And so now we have to remember here that when we square radicals, since these two operations are inverses of each other, they cancel each other out. So this is just going to be 7 plus x squared equals 19. 19 minus 7 is 12. And now I'm going to take the square root of both sides. So when I go to simplify this, again, my perfect squares, if you want to kind of write them, you might want to honestly, for the rest of this unit, kind of write them down on a piece of paper, post it or something. And I don't know, right, 2, I'm at 2 squared is 4. and just kind of have them out because we're going to be simplifying radicals for the rest of this unit. So 4, 3 squared is 9, 16, 25, and so on and so forth. So when I'm thinking about perfect squares that go into 12, I think of 4, and then 3 can't be broken down any further. So the square root of 4 is 2, and then I'm left with radical 3 underneath the radical. So this side would be 2, radical 3. All right, so we're going to now look at a couple of word problems. Now, most of the time in these word problems, you will be rounding your answer. So that's kind of the good and bad thing. These are a little bit trickier because you have to set up your picture, but you also don't have to worry about simplifying the radical. The reason why most of the time in word problems we round is because it makes more sense in that context. Like you're not going to say, oh, the distance is 2 radical 3 meters. Because we need just an approximate distance to tell the Coast Guard how far he is from the ship. So we don't want him to have to figure out what 2 radical 3 is. So this problem says a disabled ship radios to the shore for help. The Coast Guard determines that the ship is 16 miles east and 43 miles north of the station. What is the direct distance between the ship and the Coast Guard station? Okay. All right. So if I want to put like the station right here, and in all honesty, I'm going to try to draw my picture exact here, but in all honesty, as long as your sides are labeled correctly, the orientation of your picture does not really matter. And so if we think never eat soggy waffles. And so if the station is here, it says the ship is 16 miles east. So that would be this way. So this would be 16. And then 43 miles north. Okay, so here's our ship. So if I want to know the direct distance, that is going to be my hypotenuse. So when I go ahead and substitute everything in, that'd be 43 squared plus 16 squared. I'm solving for my hypotenuse, so I'll just call that C. 43 squared plus 16 squared is 2105. And you guys, I am totally okay with you typing it in your calculator like that. If we come back and you guys take I-step, you have to actually show what 43 squared and 16 squared is. And on quizzes and tests and stuff, if you accidentally mistype something, having that does allow me to see where you guys made a mistake. So you just have to really make sure you're typing in the right values here, or else I don't really know what you did. All right, and so then to take the square root of 2105, and we get, and this says what, round to the nearest whole number, so that would be 46. So that means that they're 46 miles apart. Okay. All right, so let's look at one more word problem, and then we'll talk about an extension of the Pythagorean theorem. So a standard doorway measures 6 feet 8 inches by 3 feet. So the first thing we need to do is put it all in the same unit. And remember, last chapter, we talked about always changing the bigger unit back down to the smaller one. So 6 feet 8 inches, 6 times 12 is 72, plus 8 is 80 inches, and then that 3 feet is going to be 36 inches. So we want to make sure everything is in the same unit. Okay, oops. All right, so here's my doorway. I'm going to make the smaller side 36, the longer side 80. So if I want to know the largest dimension that will fit through the doorway without bending, so that, right, the longest side is always the hypotenuse. So that means if I have this object that I need to fit through, I mean, think if you've ever tried to fit anything through a doorway, you turn it to the side, right? Because you'll fit more there. And so I want to know what is the longest thing that I can fit through this doorway without bending it. So I'm looking for the hypotenuse, and then I've got these two right triangles that I can choose from. So if this is a rectangle, most doors are, then that would be 36 and this would be 80. Either way, we're looking for the hypotenuse. So 36 squared plus 80 squared equals c squared. 36 squared plus 80 squared is 7696. When I take the square root, I get about 87.7 inches. And honestly, I probably should round down to just 87 inches because if it's exactly, it may not fit. So even if I rounded down to like 87 and a half, that might be a little bit better for this particular problem, but we'll just leave it as 87.7. Okay. All right, so that's just our quick little review of the Pythagorean theorem. This next part is called the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem will determine what kind of triangle it is. So the Pythagorean theorem is kind of a known thing, right? If a triangle is a right triangle, then a squared plus b squared equals c squared. So remember from last trimester, the converse means that we flip our theorem. So instead of saying if a triangle is a right triangle, then a squared plus b squared equals c squared, the converse is if a squared plus b squared equals c squared, then triangle ABC, or any triangle, is a right triangle. Okay. And so when you're trying to determine that relationship, your job is to identify what C is, right, which is always going to be the longest side. And then you're going to relate that to A and B to help you determine if it's right. And you can also use it to figure out if it's acute or obtuse. So are all your angles less than 90, or do you have kind of a big one and then two smaller acute angles? So a couple helpful rules to remember, and I'm going to write this kind of the opposite way just because I think it's a little bit easier to see these two. So if this is true, then that is a right triangle, right? We know that. And so if c squared is less than a squared plus b squared, right? So if that longest side is smaller than the squares of the other two, then that means it's acute. And if c squared, that longest side, is greater than the sum of the squares of the legs, then that would be obtuse. So what we're going to do in all of these is just first we need to identify what the longest side is, because that's always going to be C. And then we'll just figure out the relationship between c squared and then a squared plus b squared. So for example, in this one, 13 is going to be the longest. You might not know what radical 8 is off the top of your head. I know the approximate, but just type it in if you're not sure. So if radical 8 is about 2.8, that means that 6 is the longest side. 50 is going to be the longest side. 89 is the longest. And then same with this one. I don't really know what 3 times radical 3 is. It's 5.2, so that means it's bigger than that. So that's going to be my longest side there. Okay, so we identify the longest sides. And so I always put that on the left and then this little blank, and that's where I'm going to either fill in the equals, less than, or greater than. So if we just get all of these set up, 6 squared compared to radical 8 squared plus 4 squared, 50 squared compared to 14 squared plus 48 squared, we'll do these three first, the numerical ones. Okay. Well, 13 squared is 169. 5 squared plus 12 squared is 169. So those are the same. That makes this a right triangle. This here, just to review this radical, I'm going to do this in extra steps. Remember, when I square these, they cancel each other out. So that's just going to be 8 plus 16. 8 plus 16 is 24. And then I'm going to fill in my inequality. So if c squared is greater than 24, a squared plus b squared, that means that this is an obtuse triangle. So that the square of that longest side is bigger than the squares of the other one. Okay, so moving on, 50 squared is 2,500. 14 squared plus 48 squared is 2,500. Equal, right. Okay. So again, you're looking for the relationship between the longest side and the two legs. Okay. So this one is the same. We're kind of guessing that that would be the right angle, so that's c squared. But again, you always want to make sure you look at the lengths and not the way the picture is, because your picture might not be drawn to scale. So c squared compared to a squared plus b squared. That gives us 7921. That gives us 7921. Right triangle. Okay. All right, and then this last one here, so we said that this was our longest side. So we are going to be squaring that whole thing. So we talked a little bit about that in the 8.3 review. So remember what we're doing is we're squaring both of these pieces. So 3 times 3, the outside part is 9. And then if I were just squaring the radical 3, those would cancel, leaving us just with 3. So 3 radical 3 squared is 27. If you are not 100% sure, then just type it in, right? 3 radical 3 squared. Still get 27. Okay. And then 2 squared plus 5 squared is 29. And then we fill in our inequality. So since c squared is smaller than a squared plus b squared, that's going to make this an acute triangle. So remember, your homework is not in the stapled packet. I gave it to you separately. So you should still have a copy of it. But if you don't, you can access it from Canvas and either print one out on your own or just do the problems on a separate sheet of paper.